Now, let's explore how the client credentials flow functions when using the JWT bearer assertion client authentication method. Remember that this method can involve either symmetric or asymmetric signing. Symmetric signing relies on a single shared secret key for both signing and verification. It's simple and fast, but carries greater risk if the shared secret is compromised. Asymmetric signing uses two keys, a private key for signing and a public key for verification, offering higher security and enabling public verification without exposing the signing key. Let's start with the JWT bearer assertion using symmetric signing. Again here, we have Bob and Alice, who both securely stored the shared secret. Bob represents the OAuth 2 client and Alice is the OAuth 2 authorization server. Additionally, we include the resource server to cover all the OAuth 2 roles for the machine-to-machine client credentials flow. Here is how the flow works. The client creates a JWT token and signs it using the shared secret. The client sends a POST request to the token endpoint, including the signed JWT bearer assertion as the client's authentication. The curl command is similar to the one used in the standard client credentials flow, but instead of the client secret, the signed JWT is included in the client assertion parameter. An additional parameter, client assertion type, is included to indicate the use of the JWT bearer assertion method. The authorization server verifies the token using the shared secret. If everything checks out, it issues an OAuth 2 access token and returns it to the client. Now, let's move on to the JWT bearer assertion with asymmetric signing. Again here, we have Bob and Alice. Bob holds and secures a private key, while Alice holds the corresponding public key. Bob represents the OAuth 2 client, and Alice is the OAuth 2 authorization server. Also the resource server to complete the OAuth 2 roles for this flow. The client creates a JWT token and signs it with a secured private key. The client sends a POST request to the token endpoint, including the signed JWT bearer assertion for authentication. The curl command structure remains the same as with symmetric signing. The authorization server verifies the token using the public key. Alternatively, the client can make the public key accessible via an API, similar to how tokens are validated by retrieving the public key from the authorization server. If everything is valid, it issues an OAuth 2 access token and returns it to the client. An alternative, less common approach is for the client to obtain the JWT from an identity provider that generates JWT assertions instead of creating it locally. In this case, the client retrieves the JWT assertion from the identity provider and uses it for authentication with the authorization server. This setup requires a trust relationship between the identity provider and the authorization server, along with specific configurations such as registering the identity provider's public key with the authorization server for signature verification. While this method is less frequently used, it can be advantageous in specific project scenarios. In the authorization code flow, the process is similar. However, instead of including the client secret in the request body, the JWT assertion is included along with the client assertion type parameter to indicate the use of the JWT bearer assertion as the client authentication method.